recorded then.
Okay.
Okay, so second reading, machine learning basics for today. And so first we're going to cover some common questions and myths about machine learning and AI that you guys might have.
So probably one of the biggest questions to some of the people who definitely haven't stepped into the field of ML is, what's the difference between all these buzzwords, artificial intelligence, machine learning, and like deep learning? And this Venn diagram shows that they're all just like subcategories of others. Deep learning is a very specific algorithm that machine learning uses. We'll be covering that later in the semester with neural networks. But there's other methods of machine learning like KNN clustering. And then machine learning is another bubble inside artificial intelligence, which is simply a program that can sense, reason, act, and adapt, which is a very, very broad category that definitely doesn't necessarily need to use machine learning. There's a lot of examples, but something that goes off the top of my head is something that you can manually teach instead of learning automatically using machine learning. Okay, next slide. So these are some of my favorite memes about ML. Regarding the question, is ML intimidating? Should you start learning ML? Do you think you're ready? And these memes clearly tell you that machine learning is about as simple as it being statistics. The meme on the left shows that under the mask of machine learning, which is just a term, it's just statistics. And to the right, I'm sure you can read it for yourself. Next slide. So this is just a technical representation of how machine learning is basically equivalent to statistics. On the left side are various terms about machine learning that we'll be learning all within the first semester. And to the right are the statistical equivalents that you'll probably learn in senior year.
Alrighty. Another question that's common is, why is ML so big now, right? And that's mostly thanks to the rise of powerful computers. And for example, in 1980, the artificial neural network was introduced by Geoffrey Hinton, and it was called the multi-layer perceptron. But computers weren't powerful enough to run them back then, so people didn't know if it would actually work, and they just ignored it. But recent advancements in computer hardware have enabled training big models, which is why it's so popular today. Machine learning research has been going on for decades, but it's only in the past couple of years that companies like Google, Microsoft, and Apple have taken note and started using it in their products. Okay, so to train a model, it takes a very, very long time. And that's because it takes millions of math operations and calculations to optimize the model. And traditionally, models were trained using the CPU, which stands for the Central Processing Unit. Basically, what the CPU does is it takes instructions and executes them one by one in sequence. For example, if you had to do these 4 math operations on the left, the processor would do each one in sequence. So first it would do 2 plus 2, then 9 plus 10, then 4 times 20, then 6 times 9. And the GPU was introduced a couple decades back, and it's most often used for rendering video games. So when you play a video game, if you have a really good graphics card or GPU, you get really good frame rate. And that's because it's doing a lot of math operations to calculate things in that frame. Similarly, in machine learning, if you want to speed up the training of your model, you would use your GPU. Basically, what a GPU does is it has a lot of tiny little CPUs, and it does all the calculations at once. So unlike the CPU, which does each calculation in sequence, the GPU just does them all at the same time. So that'll speed up the training of your model by a very large factor.
So where do we see machine learning in our daily lives? So one instance is in social medias. And every time you look at a video or a post or even like a movie like through Netflix, it records what you watch in a database. And a machine learning model understands your behavior and recommends some other videos or movies or posts related to what you may be interested. It's also used in email intelligence. For instance, your spam. Although you never really think about it, but have you ever thought of just like how the algorithm finds what is spam? So it uses a natural language processing to find like which are considered suspicious emails and place them under your spam filter. You also might notice that when you write emails, like through Gmail, it prompts simple phrases to respond to emails like thank you, all right, yes, I'm interested. So this also is another use of natural language processing to find what should be used next. You also might see this machine learning in virtual assistants like Siri and Alexa, which also uses natural language processing to understand your requests and to respond to your queries. And finally, the last example is Google Maps. It uses location data and inspects the agility of shifting traffic. It also organizes user-reported traffic like construction, traffic, and accidents. And through all of that, it can reduce commuting time by indicating the fastest route.
Okay, so what will machine learning look like in the future? So here's a good graphic that shows how AI has progressed in like the past 70 years or so. So traditional AI was based more on logic, and modern approaches to AI have moved towards using more massive amounts of data rather than being logic-based. So in the modern age, there are three types of AI. So weak or narrow AI, and strong or general AI, and then AI superintelligence. So weak AI simulates how humans think, and it's usually just used to help humans complete tasks that may be tedious or repetitive. So general AI is the stage where AI is comparable to more of like a human thinking and like actually where the human intelligence is. And finally, the stage of AI superintelligence is when AI is surpassing human intelligence. So don't worry just yet because we're quite far from the last two stages. So currently, most examples of AI you see will be considered weak AI, such as all the examples from the previous slide. So because none of the tasks that the AI is actually doing require a high amount of intelligence, it's more of just using computational power. So although AI is powerful, it's mainly just looking for patterns in data and then going through massive amounts of data to find something that is easier for a computer to do than a human, although it's not necessarily that intelligent. So we are quite far from the last two stages. Many argue that even strong AI is not even possible to exist. And now we will be talking about how each of us got started in machine learning. So for me, I got started in machine learning basically through searching things online. So I had a lot of coding experience to begin with before I started, and I basically just completed a lot of tutorials from like those well-known popular machine learning libraries that you may know of. And I think that since, especially now, a lot of these machine learning libraries have simplified the coding process and like the conceptual ideas down to something that is fairly easy to at least follow along to. It's not that hard to get started. So I basically began by just copying some code and going through things until I started to catch on gradually to like patterns and then like what sort of things were being done. And from there, I kind of just, most of the things I've done are self-guided, and there's a lot of guidance on the internet or through some popular online classes that you guys might hear from the other officers.
Yeah, so before starting on machine learning, I also had significant coding experience. So throughout middle school, I would like learn different languages, just like using random websites. And then in my freshman year, I decided to do machine learning because it was like a really hot topic and it was like a buzzword. So to learn, I took a course from Coursera, which was taught by a Stanford professor, Andrew N. And it's like one of the most famous courses or like most famous beginner courses for machine learning, and it's absolutely free. I think that course was 11 weeks. So I did that like the spring of my freshman year, and it was really helpful to get all like the concepts down in machine learning. And obviously we also learned how to code it, where we learned how to code it without using any libraries. So you really like know what each library is doing. And then after that course, like you can just go on Kaggle. So Kaggle is like this website with a bunch of data sets, and you can kind of play around with the data sets and try out different models that you've learned. But when coding in like the real world, you won't code it from scratch. So then what I did was that I would just like learn tutorials, again, using like the different libraries that Claire was talking about. So I used PyTorch mainly. And then after that, you can either just like keep taking more courses or learning about like different machine learning libraries or just working on your own project.
I'll go next. I began similar to Claire with just picking a topic or an idea that I found really, really interesting. For me, it was emotion recognition from images of faces. And then using online tutorials, online sources, you push through and actually try to finish your project on your own. I went into ML with like a lot of coding experience, but not in Python. So I had to like learn Python on my own before doing ML. That went okay. uh, to learn machine learning, to be honest, you don't really need that much understanding of Python, like if statements, for loops, and the rest the tutorials will cover. And then after finishing one project, I decided to take a course. I took a course on edX because at the time, I didn't know of the super duper famous Coursera course. And I took MITx, Python, and linear models in machine learning using like linear algebra and blah, 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 blah. So similar to the Coursera, I learned a lot about the concepts and learned how to code them in Scratch, for example, with a neural network from Scratch. And then afterwards, I wanted to specialize more in computer vision. So I took another course in computer vision, going as far as using Raspberry Pis, learning about gesture recognition, et cetera, et cetera. And that was fun. My advice is pick a project and just get it done, and you'll have like one foot inside the world of ML.
Yeah, so I can go next after that. So I first became like interested in machine learning when I like attended hackathons. So I mainly did like app projects back then, but then I started realizing like what other people were making, and they're really able to make these like cool, unique, like machine learning oriented projects. So similar to Aaron and Arushi, I also began like taking some like online courses, and that's honestly a really great way to learn machine learning, since like a lot of the material like it's online, all like the concepts. You just need to be willing to like learn it and have like a curiosity to learn more about it. So I took a few courses. I think it was on Udemy. I got it while it was on sale for like $10. So that's where I started like actually beginning to learn more about machine learning. And then I just began to apply these ideas into like some hackathon projects. I gathered a few friends of mine, and we started making these different cool types of projects and submitting it to hackathons, and just seeing like how others people think about our projects. And that was really how I was able to grow my curiosity and my understanding for machine learning, was just through these projects. And that's really, I mean, wait, if you want to get better at machine learning.
Right, so my starting story was a little bit different. My dad actually works at NVIDIA, which is the most dominant manufacturer for GPUs. So my dad, like every night, would show me cool research papers and projects that his company was working on, and I would be really interested in how they worked. So I started reading how they were actually built, right? And I had no idea what machine learning was back then. So I started looking into the math and how it works. And the first channel that I started watching to understand machine learning was called 3 Blue 1 Brown. You guys might have heard of it. It's a math channel, and he has a series on how neural networks work by explaining like step by through calculus. And that was really the starting point for me. And after that, I started learning Keras, which is a very simple neural network library for Python. But then after a while, I switched to PyTorch because it's just superior in every way. Yeah, I recommend if you're starting off with Python, just go straight into PyTorch, ignore everything else. That is my advice. And after that, I started reading into those research papers again. And I now work on research papers and projects with other people. So yeah, if you want to explore the cutting edge of machine learning, you should definitely read new papers that are released in conferences like CBPR and AAAI.
Okay, so now that we've covered like the main different questions in machine learning, we're gonna go over like the very basics of machine learning.
I'm gonna assume I'm doing this slide. So this is supervised learning, which is a very broad category inside machine learning. Essentially, given labeled data, you want to output an information. With regression, which is probably the most simple version of algorithm of machine learning out there. This is straight out of statistics. if you look at the graph to the right, you have a lot of data points and you fit a line of best fit essentially to the data points. And using that line, you can make predictions at different numbers. Some things that you should note about regression is that it's continuous, which is in contrast to classification, which is discrete. Your algorithm will have a discrete output of either class 1 or class 2, or however many classes you have. In this case, if you look at the graph to the left, you use this line to separate two different types of points. If you notice, there's both blue points and green points, and the line is a line that you'll use to output a class prediction based off of the XY location. And for example, classification can be used with breast cell cancer classification based off of size and color, and regression can be used for something as simple as predicting house prices as time passes.
So the other side of machine learning is unsupervised learning. So unsupervised learning is when you're not given the labels to your data. So what I mean by this is you can see in the image on the bottom that with supervised learning, you're given your two classes. So you're given like, oh, these data points are red class and these are blue class. But then for unsupervised learning, you don't know which class is which for the data points. And your algorithm has to figure out different patterns in the data and cluster them however it feels is the best. So some examples of unsupervised learning are recommendation systems. So these are like the systems that Netflix uses to give you like new movie recommendations, because it doesn't have like data. I mean, it has data to go off of, obviously, but it's not like you don't label the data, oh, this is the movie I like, this one is the movie I don't like. You just say, it just has the data that you watch these movies and this is what's going to recommend you. And another example is like classifying cells based on gene expression. So how this works is that different cells express different genes, and then you might not know what cell is like what cell type it is, but when you run some algorithms, you can cluster the cells into different groups, and based on the genes that they express, and then those different groups will be your different cell types. So here's an overview of what a machine learning project will look like. So this is the full pipeline from like start to finish. And your first step, obviously your first step is to collect data, but then your next step would be to split it into 3 categories. And the purpose for these 3 categories, they also have different purposes. So your biggest category would be your training data. So this is what you train your model on. And then the model has like specific parameters that you need to input. Like we'll go over them more later, but some of them like learning rate and like momentum and stuff. So you need to find the best parameters for your model using your cross-validation data. And once you have your model and you have all the best parameters for your model, then you run it on your test data to finally test what your model will perform. Okay, so first, when you split your data, then you need to run the model and get its predictions, and then you want to penalize the model for the wrong predictions it's made. And then once you penalize the model, if you find the loss, then you want to update the model so that it reduces the loss. And then again, I talked about using cross-validation to fine-tune your model parameters, and then finally you're going to test your model on your testing data.
Okay, so thank you all for coming. There is the attendance code and the attendance link, and then the code is basics. And like last time, there's like a short optional section on the second page, which really helps us out in determining what you guys want to see in our future meetings. So yeah, thank you all for coming. Please fill out the attendance, and we will see you next week unless you have any questions and want to stick around for that.
Bye, everyone.
Can I ask a question?
Yeah.
Okay. So I noticed that Arushi said something about a course. Do you know where I could get the link for that or what the name for that is?
Google, Coursera, Andrew.
Yeah.
I'm sure it's the first thing you'll
Yeah,
find.
it's
I
a
can send the
course.
link also in the chat.
Is it deep learning specialization?
It's like an overview, so it goes over like all the different types of algorithms.
Okay. Yeah. I'll try to find it. You said it's from scratch, right? So.
Yeah.
So
So
I
Okay.
can send you the link here.
the instructor's
Oh,
name is
yeah.
Andrew NG is his last name.
Oh, okay. Yeah. Thank you. Also, just a quick question: is a perceptron? Because I remember you guys said the multi-layer perceptron was first ANN. Is a single perceptron not considered an ANN?
I think it's not. I mean, it's considered an artificial neuron, but not a network because there's only one.
Yeah.
If you have like two chained together, then I think it counts as a multi-layer.
Okay.
I don't know the exact terminology, but I think that's how it works.
Okay. Thank you guys. Have a good weekend.
Okay, see you next week. Thank you.